it's bad news. It's that far off. Ladies and gentlemen, welcome to the Ryan Ride Mechanic channel. How the heck are you doing today? Alright, today's video, I wanted to kind of make like a PSA out there. For those of you that haven't worked in the maintenance department, or maybe are planning on working in there, or just don't understand it, today's video is more about cutting them a little bit of slack. So, let's get into it.
Now get ready. Here we go.
First of all, thanks for coming back and watching another video. I do appreciate it. Alright, in today's video, basically I had someone email me a story. And I thought it was really amazing, and it really highlights the struggle that the maintenance department has to go through. And so when you're at a park and you're going there and a ride has a lot of downtime, a lot of people look at that as in like the maintenance department doesn't really know what they're doing. And that's a negative thing that maintenance departments always have a very hard time climbing out from underneath. Even, I mean, this just stretches beyond the maintenance department. It stretches into ride manufacturers, or the manufacturer doesn't know what they're doing. Anytime the equipment doesn't perform and it's not up and running, people always think that somebody doesn't know what they're doing, otherwise it would be running. So one of my viewers emailed me this story, and it's a real story, and it was so well put together with all the information inside of it. I was like, I wanted to use that. So normally you guys hear my stories, and I pretty much have said most all of them out here. So this is from a real park. This is a real person at a real park with real equipment that has a real manufacturer. Everything in this is real. Nothing is hypothetical. Because of that, this is a learning channel, right? I do this stuff so we can go out there and inform, and people could learn and take this to the amusement park and make sure that, you know, they understand that equipment is safe and things are operating the way it's supposed to be. And I don't ever want to try to throw a park underneath a bus. I don't want to ever put a person down that they're not doing something properly. I always want to make sure we're coming from a good place. So the purpose of this video is for learning. And if you've ever been in the maintenance department, or are going into the maintenance department, or have ever worked refurbishment on rides, this story should hit pretty good. So this story comes to us from a viewer again. Says, Dear Ryan, I wanted to share with you one of the difficult, I think the most difficult I've had to deal with, issue we've had. Hope you will find this interesting. So mid-season, we started to have sensor errors on our log flume. The flume has lifts, chutes, and 2 rotary tables. The air would fire between 0 and 4 times a day. The electric system was overhauled in years past, and a new control software was developed by a company other than the vendor. Okay, right here we've got a log flume ride. It's been faulting out 4 times a day. That's a lot. Now, people say, well, you know, we've had log flumes that fault out, or rides fault out 4 times a day. Some places don't look at that as a problem, but when you have maintenance has to show up every time to reset the air or clear something, it becomes a problem, especially once it goes past like day number 2, day number 3. That's when operations starts, and I'm like, what are you guys doing? Everyone starts demanding to know like what the department is doing to try to fix this, trying to ensure that the maintenance department isn't just going out there and pressing the reset button every day and kicking it back out. The rotary table is electrically driven by a big sprocket and controlled by a VFD and 2 sensors. One to tell the table to slow down the rotation, the other to tell it to stop the rotation. Typical sensors, right? You have a table, it's spinning, passes a little flag, passes one sensor, and it says slow down, and then it gets the other one and says stop. Okay, makes sense. There's 1 dampener cylinder that receives the boat, and 1 ejector that sends the boat down the chute. Finally, there's a cylinder with a small free rotary table that goes up when the boat is on the rotary table to keep it in place. And then it says 212 up and lock, 213 down and free to roll. Okay, so basically the boat comes in, and the table comes up and pushes, I'm guessing it's on the bottom of the boat, pushes on the bottom of the boat to basically steady it and hold it so it can't slide forward or backwards in this rotary table. The sensor triggering error 225 each time we had the error. There was no other issues. So This sucks with rides when the ride's just going and you can't find out what is happening, but every once in a while it will just randomly spit out the same error. I've done this many times. You start recording everything. You start trying to figure out, okay, like on roller coasters, which train was it, or in this case, which boat was it? Was it loaded? Was it, what time of day? Like all these scenarios try to come into this factor and trying to okay, what was the thing that caused this to happen? What was it? So, and again, every time this happens, you're eating downtime. The park's eating downtime. Guests are getting upset. Operations getting upset. Operations probably more upset than the guests because they have to deal with the guests. And that is a whole different pain in the butt that most maintenance guys never had to deal with. From the mini stops we had, the only consistent thing was that the boat was in front of 225. That's a sensor number, 225. Sometimes still entirely on the lift, sometimes half on the rotary table, half on the lift. The rotary table was always clear, no boat on it, but the maintaining device would be up, which was not normal as it should be down to receive a boat. So that's interesting. It airs out, and that retaining device to lift the boat, I'm assuming touch the bottom of the boat and hold it, was always up when this fault happened. Okay, so, but it was moving. That must mean that, I don't know. They thought it had it, but it didn't. The sensors are infrared sensors, and there is a receiver and transmitter cell. When the boats are going up the lift and the rotary table, there is a lot of vibration. Okay, so sender receivers, that's very typical on log flume rides because in water rides, you don't have a specific target to go across. Hold on. Okay, so when it comes to proximity sensors, just like this one, they have a sensing distance in front of them. And the smaller the sensor is, the smaller the distance is. For this instance, this one, I think it only has a range of about 4 millimeters, which is right about there. That's it. Nothing more. So if something goes by at 5 millimeters, it won't see it. 10 millimeters, it won't see it. One of the things about water rides is that they float. They're all over the place. They're up, they're down, they're left, they're right, they're everywhere. So you can't typically use small sensors because the boat's floating across it. It's doing this number. It can't get something like that. So you have to put something in the way. You either have to use a physical switch that has a lever arm, so when the boat pushes on it, the arm falls down, and that tells it it's there. Or the most common thing is to use infrared or optical switches that look across. So you have a sender and a receiver, you block the sender, and the receiver changes state, tells the PLC something. Either goes high or it goes low to tell the PLC that the boat is in fact there. So water rides, used all over the place on water rides. We started by making sure that the 225 sensors were perfectly aligned with each other. Then we suspect that the receiver had an issue and was losing signals, but that would tell the system believing there was 2 boats instead of 1. So we replaced the 225 receiver. Yeah, those sender receiver units have to be pointing at each other, pretty much just like that. They accept some variance. The sender sends out a cone, essentially, and not a big wide cone. It sends out kind of a narrow cone. So if this is the sender looking at the camera like this, it can only handle a little bit of variance, like about to right there. And then if it goes the other way, you've lost the cone now. If the camera was the receiver, you've lost the cone. So you have to point it back at least pretty close. The receiver is the same way. If you turn it just a little bit too far off of its center line and point it a different direction, it takes a signal and stops receiving a clear signal and starts getting interference. Most all rides are set up to where once a signal is lost, it says that there is something there, because this is typical block logic. You want to make sure that if the wire is cut, you have a power loss, or the sensor simply fails, it puts a vehicle right there to prevent an accident. They don't want to just not know a vehicle's there. So it's always, if anything happens to it, it puts a vehicle there. After that, we used a spare wire. Thank God there was a spare wire available. If not, we've been pulling about 500 feet of cable down the lift hill, along the canal, and through several walls in the station to wire 225. But the air still remained. All right, I'm going to stop here. Spare wires. Let's talk about spare wires. When most people think about spare wires, you picture that cable coming down the lift hill, coming like most things, it looks like a black cable like this, right? This is what most people say, well, this is a wire that runs between the sensor and the control room. But what he's talking about here is that inside of this, because this is not a wire, this is a cable. The difference is that a cable holds multiple wires. See, this cable holds 4 wires on the inside of it. Now, for this particular device, all 4 wires are used. But a lot of times when you build stuff, when you build equipment, you spec out cables that are a little bit overgrown. So what I mean is like this particular sensor cable that they're running, it probably needed maybe at least 4 wires on the inside of it. But then there was probably several sensors up there. So if there was, let's say, I don't know, if they were running 8 sensors, 8 times 4, what is that, 32 wires? So you would have needed 32 wires to run the 4 sensors back there, or 8 sensors back there. So what you typically end up doing, instead of buying a cable that has 32 wires in it, you buy a cable that has 34 wires or 36 wires or 38 wires or 40 wires inside of it. The deal is where that cable comes up and terminates in the junction box, you now have what we call spare wires in there. You're using wires number 1 through 32, but 33 through 40 are not being used. And if for some reason you think there's a problem, which is where they were going with this, for some reason, if you think there was a problem with wire number 15, well, you simply just take wire 15 off and you go over and you put it back onto wire number 33 and you connect it. And then in the control room, you take the signal off of wire 15 and you move it over to 33 and connect it there. Now you've officially used a spare wire in that cable. So the reference is that some places don't do that. If you needed 32 wires, you got 32 wires. And then if you didn't have that, you would have been pulling a brand new cable with another 32 wires on the inside of it. Or, done this plenty of time for troubleshooting, you use a singular wire outside of the cable and you run it all over the ride just to get back to the control room. I've done it myself. It does not look pretty at all. But it's something to at least say like, okay, we've tried. We're trying to replace this one thing, but you know what? If you're questioning whether a cable is good or not, then it's not necessarily so much about wire 15. If you need 4 wires to operate that sensor, it's about all 4 wires, not just one. And then if the thing is damaged, well, then that calls into question everything else inside that cable. At that point, we turned our attention to the rotary platform and the particular maintaining device, as it was not on the normal state down when the air was firing. When there was discrepancy between the up and the down sensors, the monitoring platform goes up, safe position, as it won't allow the boat to move. So we changed both sensors and verified the position sensor. These are basically small reed sensors. The air still remained. Okay, so basically a discrepancy between 2 sensors, it went up, which is your safe mode. The manufacturer says, hey, if you get a discrepancy between those things, we don't know which one's correct. We're going to lift that guy up and we're going to hold the boat. And we don't know what's happening, so we're just going to hold it because we don't know until maintenance arrives or someone arrives to figure out what exactly is going on. It's safe. It's like applying the brake. Brakes on. Reed sensors. Have you ever heard that before? So this is a proximity sensor, which we typically call a proximity sensor. This is a different style of reed sensor, but typically in terms that we're used to using, this is a proximity sensor. It's inductive. Metal passes by, it turns on. When we say reed sensor, this can also be called a reed sensor for sure. But typically what we talk about when we say reed sensors is actually a magnetic switch. So passing, if this were a reed sensor, which they look the same, passing metal in front of it won't trigger it. An inductive sensor, it will trigger it. But a read sensor, you have to pass a magnet in front of it in order to turn that sensor on. So those can be used outside of cylinders. That's their primary position, is outside of a cylinder. Man, I'm using all my examples today. All right, here is an air cylinder. Inside there is a piston right here. Now it's right here. Now it's right here. All right, so if I want to see what position that piston is in, I can't use this proximity sensor because it won't read through this casing. I could use it on the end because it's metal. I can use it over here, sure. But typically what you do is you buy a cylinder, which on the piston on the inside has a magnet around it. It's a round magnet that sits on the inside. And then what you do is you take your read sensor and you put it on top of there, just like that. And then what you have is you typically put it right there, one side or the other typically. And then when you say, okay, extend the cylinder out, it says off, 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 and then click, it turns on. Because now it's reading the magnetic force from the inside. So that's a typical read sensor. They typically go on cylinders to move things around. Back to the story. As you know, everything happened with the park open to the public. Of course, it never happens during run-up or testing. It's always fully loaded with people on it, every time. Every time we had this air, we would have to call multiple people to go to the lifts and the rotary table, warn people inside the boats to coordinate to restart the ride. Each time it was 9 people. Oh my gosh. Oh, 9 people. Oh, that sucks so much. One on lift 1, 2 on lift 2, as it's the longest, before the final chute, 2 in the station to give re-entry and deal with concerned guests, 1 technician to put the lift 1 in the rotary table to manual reset it, 1 technician at the operator booth, 1 supervisor from ops to coordinate, rushing to the ride to get it back up and running ASAP. Yeah, you can imagine the pressure we had to get this issue solved. All right, this is a massive drain on resources. This is something like after a couple of times of doing this at my old park, we would have had operations standing there like refusing to run the ride because they didn't want to deal with it. Operations didn't want to deal with it. They wouldn't want to deal with the heartburn that comes from the guests. The guests would get irritated. Like there's so many things going on here that just makes this an undesirable, just all-out crap situation. It's bad news. Man, that sucks. 9 people. At this point, we looked at every sensor on the rotary table and lift. Every connection and sensor was tested and checked to see the proper functionality of it. We never found anything. So that's bad. It's a ghost in the machine. This is typically where shotgun troubleshooting comes into play. So the term shotgun troubleshooting is from firing guns, right? When you fire a bullet, you have one little tiny projectile that has to go downrange and hit the target. You get one shot to hit the target. A shotgun doesn't have one little tiny bullet on the inside, unless it's a slug, then it's pretty big. Anyways, it has shot loaded in it, so it looks like little tiny BBs, little tiny metal pellets on the inside. When you fire that, they don't go into one little spot, they fan out and they hit a bunch of stuff. So when we say shotgun repair, this is a term we typically throw around when the maintenance department, because that's who's typically doing it, doesn't really understand what is happening and why it's happening. They're just trying to get it fixed. So in this case, they tried the sensor. It wasn't a sensor. They tried the wiring. It wasn't the wiring. So at that point, you start throwing stuff at the ride. You start doing shotgun repairs. I'm going to replace all the sensors in the area. I'm going to pull a new cable into that. I'm going to put a new lifting cylinder in there. I'm going to do all this stuff. What's the reasoning behind doing that? And it kind of boils down to like, I don't know. I don't know what's going on. So I'm just trying to throw stuff at it and hope that it fixes the problem. And then if it does, then you can look at what you took off and be like, well, what's wrong with this thing? Why did that fix the problem? That's typical shotgun troubleshooting. It's not necessarily a bad thing, but it's kind of when people are at their wits' end. That's kind of where you get shotgun troubleshooting from. Then we thought of what had changed during the annual maintenance. We painted the ride, put new lighting, and did a lot of structural steel on the job. There's welding. For the first lift, the workers sanded, welded, and painted a lot of plates near where the cables ran. Welding, a lot of heat, 1700 degrees Fahrenheit. Sorry, don't know what that is in Celsius. Computer, what's 1700 degrees in Celsius?
1700 degrees Fahrenheit is about 927 degrees Celsius.
927 degrees Celsius. There you go. All right, so it's pretty hot. So we usually check the cables and measured the continuity and isolation while we jerked them around to simulate the vibration. We didn't find anything. Okay, they checked for continuity on the cable. That means they took the wires from both ends and they used a meter to make sure the meter said, yep, electricity can pass all the way through that wire. And then they shook them around and they're looking for that signal to drop out, saying that there was a break in the wire. Not the case, it didn't do anything. Then they checked the insulation. Now that's not so much physical. What they did is they took a different meter, put it on that wire, and then they hooked another meter to the ground essentially, and then they energized this wire, isolated from the system. They energized this wire with about 1,000 volts. And what that does is that measures the bleed of the cable. It's how much is bleeding out of there. And the value should be extremely high with 1,000 volts on it. So they're making sure that it wasn't something like intermittent to where like every once in a while the conditions got just right and it essentially arced and shorted out to a metal support somewhere. Check the resistance, good. Check the sheathing, good. Check the insulation to ground, good. Next, we put all the show lighting in another color as it was red. We thought that the light could trigger the receiver sensors when it goes through the water droplet or reflection of the boat. The air still remained. Okay, optical sensors work optically. So one of the things that you always run into problems with, everybody from every part, they will eventually have a story about this, I guarantee it. Optical sensors running and sunlight, they play with each other a lot. Our floorless coaster, the thing had optical light curtains on both sides as a typical safety feature on floorless coasters. During our fright time of year, always during one particular, like a week long, the sun would get just in the right spot and it would go down to the receiving eye at the other end of the station, and the ride would go down with people on it because we could not dispatch that train out of the station. The only way to do it is like once it happened, we had to get a bunch of team members around. They had to get like jackets and stuff and create shadows for the light curtains, enough to dispatch the train out of the station, bring the next train into the station. And once they got that and got those people off of there, they had to stop operation of the ride for about 10-ish minutes until the sun changed position enough to continue on. So I totally get what they're doing. They're like, hey, what happens if the red light is reflecting? Red's the longest wavelength. So like, what happens if the red light's reflecting somehow and it's messing up these eyes? I don't know. It's probably a DMX style light, so they just went onto it and changed the program to it, and they changed it to a different color. So like, just in case that's it, let's change it. But nope, the error still remained. This is a nasty problem. Like, this is really nasty. That's when we got the long process started. We put a PC directly connected to the PLC to monitor software and record the entries outputs. Due to software limitation, we could only monitor 8 entries at a time. Sometimes the recorder would crash. All right, we had this really cool thing. I've never seen it again after we used it at the park, but I'm sure somewhere it's got it available. They called it a cracker box. I can't remember. I think maybe it was spelt with a K, cracker box. But anyways, what it was this computer. It was really cool. It was this thing that sat there, and you can plug all these wires into electromechanical relays and stuff. They would pierce the skin so it would sit on the wire, and it would record the value. You go into the computer and you'd say like, okay, this value is this wire, this value is that wire. I want your signal to turn on at this voltage and turn off at this voltage, and I could just let it sit there and record for hours and hours and hours, and it would record the data. Or if I really went to I wanted to know exactly what was happening, I could set it to the smallest interval. You had to be right there when it tripped. So as soon as the thing tripped, you had to press stop recording basically. but I can get the intervals so tight that I could literally watch the AC wavelength going through a wire and record it at multiple spots. So we have this thing where we were dropping the signal out of these relays, and they were all daisy chained together. It goes through 1, 2, 3, 4, 5, 6, and we lost the signal somehow. So we hooked up the cracker box to it in between each relay, 1, 2, 3, 4, 5, 6, all the way down there. And we can watch the wavelength literally pass down this wire. And as soon as it faulted, I was there. It was stop. We hit stop recording on that thing and watched it. It was down to the milliseconds range. And we can watch the wavelength go, and then it would just stop. And it's like, haha, right there between these two contactors, it broke. So we took that contactor out of the loop, placed it with another one. Ride was back up and running. I mean, we spent probably weeks and weeks trying to fix that problem in that ride. It was crazy. Cracker box. All right. We found that the error was triggered because the rotary table was locked, in quotation marks. The locking of the table was because the maintaining device was up. So because the thing raised up, the table locked. Okay, so something's still out of position here. At this point, we monitored the maintaining device go up command and found out that it was never triggered. What? Okay. So you typically tell something to go up and it goes up, but in this case it was never triggered. We hit a wall and stalled during some days on this. After careful program review, the maintaining device go up command was there but never used on any output. Okay, so it's in the program, but it's not being used. I've seen stuff like that before. The cylinder would go up when it loses its maintaining device go down command. Fun fact, rotary platform 1 and 2 are similar, but they don't use the same programming. The go up command is used on rotary platform 2, but not 1. That's interesting. So they basically, so as a programmer, I could say program the device to go up, and then on the other side I say program it to go down. But as a realistic, like this is what we're doing out in the real world device, I would use a relay. And I'd say, you tell me to hold the device down, and I will tell that device to go down. And then when I stop giving that command, that relay opens back up and the device goes up. Now, what does that buy me? Power failure, broken wires, PLC loss, anything like that. That device will return right back up. I didn't have to wait for my up command. Kind of a smart thing depending on how it's being used. So not bad. Once we were doing diagnostics with people on the rotary platform and myself inside the cabinet near the PLC, I switched I/O cards to see if there could be issue with the cards. We were in contact with the radio, and when I spoke near the PLC to the radio, the ride completely shut down. Yeah. The radio wavelength caused an intern fault on the PLC. The ride was down for the whole day and part of the next day as the program was lost in the PLC and there was a critical material error. We had to reset the PLC and upload the program again. Oh my gosh. It says that was another nightmare. Totally. Plenty of things when you're inside of ride control cabinets and especially in close proximity to things that are sensitive. We had DC drives that would do that like crazy. We'd take the radio and we'd key up on the radio to talk, and you could hear things inside the cabinets click. Like we had this on our wave swinger ride, which was a Zamprilla flying carousel. It had these DC drives sitting there, and you could watch them, and the ride would be running full bore, and you key up within about 5 feet of those drives. You key up to your radio, and they would get the command to slow down. Now, the thing is, the ride wasn't feeding it that command. It wasn't doing anything else, but it messed with the resistors on the board to where when you clicked it on, the drives were like, slow down, and then you take your finger off the button, they would just speed back up again. I was like, go outside of that control room to talk on the radio, please. So this crashed a PLC, and then it messed it up. Said critical material fault, which means that its processor was like critical fault, could not recover, had to reload the program. That sucks again. During the careful program review, we found that other programming weirdness, I love that, logic completely bypassed other lines that don't do anything but still run in the program. I think the programmer didn't clean up after themselves or the commissioning. This happens, so programmers put stuff in there as kind of like jumpers and like half thoughts of, wait, we could do this, and that part of the program was built but never used. And sometimes the programmer opts just to leave it in place. It's basically abandoned and placed inside the program because there's that part of a programmer that thinks like, did I use that somewhere else? I don't really remember, and they're not quite sure of what implications they have of taking it out are. The other thing that programmers do a lot of is they simply just forget they put it there in the first place. It's like, oh, whoops, left it there. The program was redone. I'm not sure if that was the original program or if that was the one that was redone in the earlier years. So we traced the maintaining device go down command and found out that the root cause was, are you ready for this? Is everyone ready for this? It's been forever, I know. It's like, hurry up, Ryan. I know. So we traced the maintaining device go down command and found out that the root cause was the water level in the chutes being too high. Are you effing kidding me? Seriously? That was a really weird one. There is errors for the water level programmed into the software, as every ride typically does, every water ride does. But they happen if, big if the water level is out of place for 3 seconds. Okay, because when I'm measuring the water level, I don't want a wave to come by and go, oh, my water level's too high, because what's followed up by that? Ooh, it's too low again. So yeah, you give it a bit of a time delay and say, okay, you do this. It's like, all right, 3 seconds. The logic used for the go down was not the same as the logic to trigger the water level errors and would fire instantly. So basically one had a timer on it to fire, the other one did not. So one part of the program started working before the other part of the program and caused an error. The water level was too high when the timing of the boats going down the chute would synchronize the wave of the previous boat. Oh, I see. So when the waves kind of synced up with each other, at that point the water level was too high and was basically like 2.5 feet measured during 1 to 2 seconds. That was it. That's a small little name. I mean, that ride's pretty fine. Like on our chute-to-chute rides, we had timers that were set up at like 7 or 8 seconds of water level discrepancy. Like they were pretty high up there. When we got to that point, we remembered. So that's the fault. That's what they found out. Oh, it's the water level. Why? That question is still there. We haven't answered the why water level part, right? Yet? No. All right, so when we got to that point, we remembered that we changed some rotting wood planks that controlled the pump's output in May. They should have been cut a little too big, so we just removed about 3 inches of these planks. Checked that the water level was in range and never had an issue afterwards. Okay, so the planks were covering these pumps. They were too big, so they cut just about that much off of them, and then the ride worked properly. So basically what was happening is that the waves were syncing up, but because the pumps weren't pumping enough water efficiently, the waves should have died down quick. But because the waves were moving slower because there was not enough water flow, that caused bigger waves, which caused the ride to fault and shut down. Okay. This issue was happening in the summertime when people were away for vacation, so it was difficult to have them working on the ride, and the issue being intermittent was also another issue. It would take days to have the proper data collected to prove the theory. The fact that the PLC software on the computer was sometimes losing recording was also an issue. This took us about 2 months to solve the issue. So all this stuff that's been going on right here took them 2 months of doing this. 2 months. You think about it, this was mid-season, so this was every single day pretty much for 2 months of dealing with this. 10 people, ride shut down, all that stuff, because boards were replaced that were just that much too wide. That's all it was. All this trouble, all this everything, all these things I went through was because it was that far off. The wood was that far off. The little things that take rides down is just insane to think about sometimes. Mechanics and people that have worked on rides are all, they've got stories going in their heads right now. Everyone's thinking about it. They're like, oh yeah, this one time. Oh yeah, this one time. Everyone starts thinking about these stories. This was a great story. This was real. All this happened. And this is some amazing stuff. So if you're no relation to maintenance and you're watching the video, if you made it through this far, subscribe. Please. But if you're just general public and you just like going to parks and stuff like that, that's absolutely awesome. Just remember the next time that ride keeps going down midday and stuff like that, that there's a reason why that's happening. And the park is trying. They're trying to get that thing back up and running consistently. Sometimes it doesn't happen for a while. Sometimes it does. It all just depends. Anyways, what did you guys think of the story? I thought this was great. This was so detailed. So much information on here. It was amazing. Like, subscribe, share, do all that stuff downstairs. It helps me out. I do appreciate that. If you want to email me, go ahead. It's ryantherideMechanic@yahoo.com. If you want to just leave a comment downstairs, that helps out too. You want to help me out? Go watch another video. I appreciate that as well. So much in this video happened. Like, this is crazy. For not actually doing anything, so much happened. It's just like this hurt my head talking about it, because it was like, what was this? What was that? I mean, they went through and systematically answered everything, and I felt like I was right there during that troubleshooting, because it's all the same stuff I would have done. Yeah, replace this, let's check that. Are those aligned? Yep, all this, that. And at the very end, it's like this much off the wood of all things. Or the wood? You freaking kidding me? Stay off the air gates. Bye. The text, it broke down for this, and you just do like the